to another Ziti TV day. Let's see, it's Friday, September 8th, and it'll be just me today. I'm trying to organize my little environment here so that if people chat at me, I can see a chat message. And what's on the agenda for today? Well, let's take a look at my screen, but I got to get the old PowerPoint presentation up there so that you see what I want you to see. On today's Ziti TV, we're going to be doing a working session. A level good working session gives you an opportunity to ask me questions. It's kind of like an office hours if you want. If you want to ask any questions about Ziti, please feel free. Just go into the old chat and chat away. And then we'll make it kind of like a little Twitch stream, except here on YouTube. So it's a YouTube stream. So yeah, it'll be a working session, and I'm going to take a look at automating an OpenZiti overlay network. And then I'm going to take a look at some of our code that me and another engineer here have been working on. We're going to clean that code up, and the idea is we want to make a nice little demo for people to be able to try OpenZiti nicely, easily, friction-free. And so that's what we'll be working on today. If you want to play along with the home game, you can play along with the home game. If you want to just watch me stumble and bumble my way through some Golang code, please do. It's always a good time watching somebody else write some code. You might learn a thing. You might feel free to mock me. I'm here for it though. As usual, what we do on Ziti TV is we go and we check out to see if there have been any releases, and I see an 0.30.3 has come out, and looks like mostly just bug fixes in there, and that's what it was. Nothing but a bunch of bug fixes. So no new interesting features, but always nice to see OpenZiti continuing to fix bugs that get found. All right, so with that little intro, let's talk a little bit about automating OpenZiti. So OpenZiti is, of course, built with APIs first. So there's an API for everything. Whenever you use the Ziti, let's take a look at the Ziti CLI, shall we? So whenever you first start getting involved in Ziti, you might find yourself typing the Ziti command, and you might think that CLI, the command line interface, is the only way that you can access your OpenZiti overlay network, but of course it's not. The Ziti CLI is actually using a REST or HTTP based interface API. And so there's a REST endpoint, an HTTP based endpoint that's sitting somewhere locally out in the cloud, wherever it might be, that is accepting requests. And if I SSH to the one I'm going to use, this happens to be in Amazon, I can do my Ziti login. I can source my Ziti quick start IP, ip.env, and then Ziti login. And there I've logged in. So this is the Ziti CLI. So what actually happened here was the Ziti CLI, also written in Go, has gone out and sent a correct request to the server listening on port, in this case 8441, LNTP, and then 8441 because I followed a quick start for this, and authenticated. And so once I'm authenticated myself, I have created an API session. Let's see if I see that Ziti Edge list, API sessions. You see, I do see a bunch of them. So can I delete them all? Ziti Edge delete API sessions where true. Chug, chug, chug. And now if I list my API sessions, I just have my session. If I do that Ziti login again, and then list API sessions, you see I have another session, and my Edge router has shown up. So it now has a session. It fixed itself. And so those are API sessions, and those are all through an HTTP based interface. If you go out, actually, let's take a look at our doc real fast so that we can see how you could get to this as well. If you come out to reference, there's a developer section, and there's an APIs section, and then there's a couple of these that show you what the latest version of the docs are. But if you just leave it on APIs, you'll see down here, specifications and documentation. You can actually get at the doc for your running controller, And I do recommend you get the doc for your particular controller, because things do change, and if you're on an older version, it might not look the same. So let's come over here, go to https://paste 8441. Also, let me know if that music's too loud. I could never tell. But since it's just me giving you a little background music, see, if you go to /edge/client/v1/docs, you can see your documentation. And so in here, there'll be something for authentication right here, and requires either password or cert or external JWT, and you can explore the OpenZiti controller API, or in this case, the Edge client API, because there's also the management API as well. Out here, go to management. Management also has an authentication endpoint and other different things, right? So 2 different APIs. This management API is the one that you can hide by creating a different web listener in the Ziti controller configuration file, and taking it entirely off the internet as well, because this is the one that modifies your network's configuration. So you want to be careful with this particular API. I don't know if I've done a Ziti TV on that, but if I haven't, I could always go through it again. Anyway, what we're here for, we're here to look at Go code and not HTML and not build.sh. All right, so I've got a little project that's out here. Stefan and I have been collaborating on it. So if I cd to my GitHub and to my Stefan and to my OpenZiti demo, and I do a git info, which is a git command I have, you can go out there and find where this code is if you're interested. It's probably not going to stay here for terribly long, but it's there for now. And so this is where it is. And if I'm not going to pull because I don't want to cause any problems. My little demo works. So in fact, why don't we see the demo real quick? All right. And so I have, let's see, Control C, we'll clear all this out. We'll clear all this out. We'll clear all this out. And so what we're looking at here, 3 different terminals. In this particular terminal, I am going to run a clear, so I clear the screen again, a gob, which is my alias for remove the Linux build directory, make the Linux build directory, and then go and build all the things and put it into the Linux build directory. I call that gob. And so I'm going to clear, I'm going to go build, and then I'm going to execute the executable that was produced. So we'll go ahead and do that. It really doesn't take very long, and what you'll see is it's already done building. I know that because it's generating a 4096-bit RSA key. That I know is part of my main function, and it's not in WASM where it was. I'm playing around with some WASM stuff too, just trying to goof around. So we have a create identity in here. Oh, and actually give me 1 second, because I don't know if there is a bad word. Sometimes there's bad words. You know how it is. All right. Good. So we seem clear. We seem clean and pristine for our main function. So in the Go world, in many worlds, you've got a main function. And so I know that when I see the creating an RSA key, I know that what's happened is I've actually already created a service. I've already created an identity, and I've gone down into the enrolling of that identity, which is this little function right here. And so I said, what we're going to do is we're going to explore the Golang SDK, and we're going to explore modifying an OpenZiti overlay network. And so we're going to see the demo work, and then I'll explain it all. And so here, my server is running. You see new service session, a couple tokens. And so what I can do now is I can go to a web page, and I can go to local host 18,000. And I get the most amazing fields, page index HTML you've ever seen. It's as though a designer designed this. It's just so pretty, or not, right? It's just a button, but I can give any. It doesn't have to be an email. I can just give it my name. So we'll say, let's see, Ziti TV. We'll say, and then it says, "Hey, great, you have created an identity already." And so we see how fast that is. What we can do is we can come over here and do a Ziti edge list identities, and then we can say name contains Ziti, and I should see unauthorized. Oh, it's because I'm not on the machine. SSH to CD AWS again. And let's go and copy this and paste this and source source the .ziti. Common problem. I know everybody hits that at least once. And then I should be able to do this. Hey, there we go. So now you can see I have a new identity. I called it Ziti TV, and it's been given an attribute. If you're not familiar with OpenZiti, attribute-based access control. I could even provide a link to our little explainer. Lots of people actually watch that video. What's the difference between ABAC and RBAC? Yeah, access control. Role-based versus attribute-based. And so with this attribute, I've basically given this identity the ability to contact the Reflect server. What's the Reflect server, you ask? What a good question. If we go out to the SDK Golang, and if you were to go to the example and to the Reflect server, you can see this is the Reflect server. This is what we're going to run right now. This is a demo that you too can run right out of OpenZiti's SDK Golang repository. So that's what the Reflect clients means. It is giving the identity that's going to connect to this server access and authorization, I should say, to be able to contact the Reflect server. And so this is what we're going to end up doing. And so you can see I've already created that identity. If I come back to my demo, now what I can do is I need to enroll the identity. So I'll do Ziti edge enroll, and it's not JSON. It's, oh, I didn't download the JWT. We got to download our token first. Let's go back, download our token. Token.jwt, perfect. Now I can enroll that token. And when I do, you can see that same generating RSA key that happened up here. That's how I know the server had started, other than the fact that it tells me server is starting on port 18,000. And so now it's written this token file. So what I can do is run that gob again, go build, generate the reflect binary, which will be for me in the Linux build directory, and then it's going to be called reflect. If you run that, it tells you that you can run it as a client, and you need to pass it some flags. Some are required. And so we'll say run it as a client, give me the identity file that's at mount vtemp token.json, and the service name is reflect service. And if you didn't know what the service name is, well, you can just pop back over to OpenZiti's CLI and run list services. I have two services, one of which is a Reflect service, that's the name of it, and one of which is HTTP service. And so I can run the Reflect client against the Reflect service. And when I go, you can see some little information. Found your service connected to the Reflect service. You may now type a line to be sent to the server. So this is a line. And when you send it, you can see up here, the server actually read this is a line and responded with you sent me this is a line, and then the client received the same thing. I can actually run this exact same program again. If I go to the reflect, not exercises, it's examples. If I run this again, I can say this is my second client. See up here, it says you sent me, this is my second client, and down here it received, this is my second client, and I can hit enter there, I can hit enter here, and I've got a demo. So that's what we're going to look at. How did we do that demo? And that's basically what we'll be talking about. All right, so we've talked a little bit about OpenZiti and services and identities. Let me show you again, what is OpenZiti? If you're unfamiliar, OpenZiti is an overlay network. And what is an overlay network? It means it's a network that is built on top of an underlay network. What is an underlay network? An underlay network is an IP-based network. Usually it's going to be IP. Everything's IP nowadays, right? If you go out to our glossary, you should be able to find underlay, and we refer to the lower level network as underlay, and hopefully we have an overlay. Let's see if we have the word overlay in here. Doesn't look like it. Oh, right here, network overlay or overlay. Yeah, so this is a network that runs on top of another network, hence the name overlay. All right. And so OpenZiti is an overlay network. We have an SDK-based application on the left. That's our Reflect client, and an SDK-based application on the right. That's our Reflect server. And so what did we do? We basically, I've already stood up an OpenZiti controller and an OpenZiti edge router. I ran all this stuff myself. And then I created the identity for the client and the identity for the server. And I stood up a server that it basically exposes all this sort of stuff. And so that's what this demo project does. Let's go back and look at what that demo project actually does. So when we come in here, we find our main function, and we see we're doing some setup type work. You can see we're deleting an identity, we're deleting an identity, we're deleting a service policy. A service policy is what permits a identity to take an action. In this case, you can see, since it kind of hints it's a bind service policy, it's deleting the bind service policy. And then we have a dial service policy. By the way, bind means your identity acts like the server. So OpenZiti, very important idea, when you have an OpenZiti SDK in your server and your server listens on the overlay and not on the underlay, then your server is unattackable from the underlay. That's a giant superpower of OpenZiti. You can find our superpowers playlist to find one of the many superpowers, but it's a giant superpower. Now your application, your server, is not attackable by anything on the underlay. You need to be on the overlay to even connect to the service. And then if your application has an authentication tier inside the application, then you've got to defeat at least 2 levels of security in order to compromise that particular application. That's why application embedded zero trust is, in my opinion, in our opinion, the future. It's where everything should be getting to, and I'm sure we'll see it someday. So we're cleaning our house, we're deleting our identities, we're deleting service policies, and then we're deleting the services even. We're getting rid of all of it. Then we're going to recreate these things. We recreate the service, we recreate the HTTP service, the Reflect service, the HTTP service, and then we give it a thing called attribute. Remember before I was talking about attribute-based access control? Well, here we're calling it Reflect services. And what we're going to do, I think, what makes more sense is to kind of clean this up a little bit. So if we come over to Ziti, we can do a Ziti edge delete services where true, delete all of our services. We can delete, if we have any, but we'll delete our configs with an S where true. We'll delete even our identities. IES where true, and then it says I can't delete myself, fine. And then service policies, I spell it out, I suppose. Service policies. Okay, so now we should have a pretty clean, pretty pristine OpenZiti environment if I do a Ziti edge list. Identities, we do have some Clint again. That's interesting. So the delete all did not delete all because it maybe either got stuck or it hit the 10 limit. So let's try this one more time. That's fun. So it actually, once it hits the default admin, it won't continue iterating. Good to know. I think that's something that we probably should work through identity. We'll just do it this way. And now if I list my identities, there we go. So I can't delete the edge router. So the edge router's identity is special. Let's try deleting it. Can't be deleted. The edge router itself is special. The edge router is working in tunneler mode in this setup, and because it's in tunneler mode, it gets its own identity. Not relevant to us since we're going to be using application embedded zero trust all the way through. So now we have a brand new clean environment, and what we're going to do next is we're going to clean up some of this code, because I don't want it to be called reflect server. I want it to be called demo servers. And I want the, I don't need to delete the reflect client. And so I'm going to change all these reflex to demo, just because these are demo type services. I'm going to leave the name reflex service because I do want to call it reflex service, an HTTP service. And when I create my service, I don't want to create reflect service. I want to create demo. How about services instead? And identities, and these are services, and that's the attribute. Yeah, cool. Demo services. Okay. Now when this executes, it's going to delete a bunch of things. It's going to create two new services. One service called reflex service, one called HTTP service, and keep them both to the same attribute. Now let's look at create service. Create service is a function that I wrote, that actually Stefan wrote. We have a bunch of sample code, like Andrew, who made the client library that we're using here from our OpenAPI spec. He created the library that we're using in order to automate the API. And so if you have your favorite language and you have an OpenAPI spec, you can, I'll say usually, generate a client that works from the OpenAPI spec. Every generator is different. They all implement, I would say, some set of the features, but I don't think I have ever in my entire life seen a generator that generated all the features correctly. So hopefully the API spec will work for your particular language, like Python or C# or .NET, or well, I guess that's .NET, C#, whatever, right? Java, you get the idea. We have already made one for Golang, and we use it a fair bit, and we use it in our tests. And so that's what I'm going to use today, because Golang is relatively popular, especially when it comes to CLI, command line interface programs. And so here we are. We're creating a service. The first thing you can see is we're setting a variable called encryption on. Now, by default, encryption is on. You have to go out of your way to turn it off. And what this means is end-to-end encryption. So when that client talks to that server, they're going to negotiate a key, and that key they're going to initiate an exchange so that they can end-to-end encrypt their particular channel to each other. I'll put it that way. And so that's what encryption on means. Then we're going to give it a name, and we're going to give it attributes. And we saw those attributes before, just passed in as a single string, and whatever the attribute is, we'll just use it. And then we'll use those that service create structure, and we'll use it in a create service params object. And then once we have our create service params object, we'll call create service, and we'll make sure that it works. And that is all it takes to create a service in an automated fashion using that handy Go API client that Andrew wrote. So you can see REST model service client. And if you look at this code, it's ugly, right? It's going to be generated code. So just make sure it says warning, it's generated. You shouldn't be changing this thing, and don't blame us when the API is a little clunky, because generators implement various sets of the features, as I already said. So anyway, you don't have to use the generator. You can write your own code. You can copy and paste it if you want. If you want to make it cleaner, go for it. But this is all that it takes, right? So we have made a service create, and this is sort of similar to running the Ziti edge create service bob minus a bob attribute. Yeah, you got to do it in the right computer again. I'm just thinking that all my shells are the same. They're not all the same. There we go. Ziti Edge List Services. Now you'll see I have a new service named Bob, and it has the Bob attribute. And that's very similar to what we're doing. We're going to delete that guy now. Delete. I should just type it out. Delete services. All right. And that's very similar to what the create service function is actually doing. Way up. Okay, we're going to go way up here. We don't need any of this. Oh, actually, that's kind of interesting. The other thing that you'll need to do, of course, in order to perform automation is you'll need to have a username and you'll need to have a password. There's just no way around it. In this case, to keep it simple, I've made an environment variable and I have read the environment variables into my environment. And so this is what this does. It's getting the OpenZiti user, the OpenZiti password, the OpenZiti controller, and then the router name, which I don't think is actually used in our particular example here. It's not. Yeah, so in fact, get rid of that. Maybe we'll need it someday and I'll be sad that I deleted it. And then what happens is you need to confirm the controller that you're connecting is the one that you expect to connect to. So you need to feed the client a bundle of certificates which you want to trust. And so that's what these little steps right here are performing. So the first thing it's doing is it's using whatever address you told it to use. It goes out and it gets the well-known CA bundle. The well-known CA bundle follows a spec that I don't remember anymore what the number is, but we could always find it if that's interesting to you and you want to know. Where's my EC2? I've got to find the actual location. Where did I go to the docs? I went to the docs somewhere. So I'll just do echo external. I'll get this. And I'll do over here, https://paste://844.1/.well-known. This .well-known is a new standard. No, not about new, but I mean, like, it's not been around forever and ever. And then there are a set of well-known CA bundle, CA certs. There are a set of well-known endpoints, and that's why it's not well-known. There are a set of well-known endpoints that you can obtain information from, and this is one of them. So what we can do is we can go out here and we can hit that particular location, and you can see a PKCS7 file has come back. And so what this has done is the OpenZiti controller has actually composed a bundle of all your certificates that you have configured the controller with, and then sent that down the line, and the edge clients use that in order to connect. And so in this case, we're connecting through the Go SDK using the REST API that Andrew wrapped around in the API, the Golang API that wraps the REST API. Oh my goodness, so many words API. Anyway, we need to get those certs so that we can make a new CA pool, because we need to provide the CA pool to the new Edge management client. Now, you don't need to fetch the certificates. You could pre-fetch these certificates and thus, explicitly trust whatever controller you're trying to get to instead of getting them dynamically. But getting them dynamic, it's just easier for people if the code gets it for you. So like if you go out and try this will be easier than you having to make a CA cert bundle for yourself. And so that's what this is doing. And then it logs in. And that's really all that happens in this little init block. Once the little init block is done, then I can go and I can actually manipulate the overlay network using the delete commands, using the create commands. And so if we take a look at the delete identity, you can see it looks similar. The API that you get from the HTTP endpoint is similar to, but not particularly identical to, the Ziti CLI. That's also important because if you'll notice right here, the first thing delete identity is doing is it's finding the identity by name. And that's because the delete HTTP endpoint will require you to pass the ID to the endpoint, not the name. If you were to go and remember back here when I did a Ziti edge delete identity, I tried to delete it by name. And so the Ziti CLI is doing exactly this. It's doing a quick little find to get the identity and then passing the identity back to Ziti to actually delete it. And so using this particular library, which is, let's see, where can I find it? Delete params, where are you used? Right here, delete identity. And this is in, where's the package? Package identity. And then we're looking for this right there. The edge -API is the actual API that goes through and allows you to automate all these things. I don't know. I'm pretty sure every single API is represented inside of here. I have not tried every single API, but I would imagine every single API is used in here. And I know we use this to do testing as well. So I expect it's relatively well tested. And so like terminators and services and routers and posture checks and posture queries and listing things. Basically every command that you can do in the Ziti CLI has to be exposed by an API and an HTTP-based endpoint somewhere. And so that's what this is all about. Okay, so I'm like 30 minutes in. That is a little bit about how I automate the OpenZiti network, the overlay network itself. Our little demo here, you can see is, let's go back to the top again because it's going to take me to scroll forever. Our little demo is not doing anything particularly fancy. It is creating deleting all our stuff, then creating a service, creating another service, creating an identity. This identity is for, oh yeah, we should change this. That's what we were doing for demo servers. So the demo servers means this identity will be able to bind or host or whatever you want to use the term, an actual service. And so we'll need an identity that is called demo server that has an attribute of demo servers so that we can create an identity that actually will allow us to host the identity or host the services. Let's clean some of this stuff up too. We don't need that. What's our little angry warning all about? Unhandled error. So create identity must be returning an error. No. Unhandled error. More actions. Main create identity name. Is that an error? No. Huh. Well, I don't know why it says unhandled error. I don't see an unhandled error there. I guess I'll figure that out in a bit. And then we're going to enroll that identity. So there is a function in the SDK. Now this is the Golang SDK at this point. So this is actually we're taking two SDKs: the Go SDK that lets us automate the API, and the Go SDK that lets us interact with an OpenZiti overlay network. And so we've used our automation API to create a JWT file, a one-time token that we're going to enroll to produce a strong identity. And if we go back over and look at when this thing started up, you'll see generating 4096 RSA key. That is the creation, the first step in the creation of that strong identity. And in the example here, we're not actually emitting this file. We're recreating this identity every time and never emitting the file. It stays memory resident. We can take a look at that in a second. And so we're enrolling I wanted to see the actual function. So we find the identity. And again, this is stuff that the Ziti CLI oftentimes will do for you that you have to do when you're using an SDK. But our SDK wants you to, not the SDK, the automation API, this API over here. When you create the identity, we don't return to you the token. You have to go fetch it. And so that's what we're doing here. We're finding the identity. Once we find the identity, we're creating delete identity params. Oh, detail, not delete. So then we're getting the details of the identity. Again, the API, you have to go get those details. It doesn't give you them because, instead of bringing you this, it gives you this. And then if you want to get this, you go get this. And so that's what we're doing. We're going and getting the extra details here. Once we get the extra details, then we make sure that we can read that token, whatever that JWT is. And if we can't, then that's too bad. And then we enroll that token. And so we the active enrollment. Again, now we're into this API, the actual OpenZiti SDK, the Golang SDK. It returns a ZD config pointer and an error. And so a ZD config pointer is basically a in-memory representation of your strong identity. We can take a look at what a ZD config looks like. It looks like an identity file. So you'll see a ZD API, which represents the URL that the SDK Golang will connect to. We'll see config types. These are the ones which you have specified that you wanted to return. Oh, it says right here. An array of string configuration types will be requested from the controller. The actual identity, and then some credentials. And the identity config is actually the one that has the key, that 4096 key that we talked about, a cert, so that the identity can be presented to other components of the overlay network. A server cert, not particularly useful in this case, a server key, and alt server certs. These are things that you generally, I think of, are more for the OpenZiti server parts, the router and or the controller. But the key and the cert, those are important pieces of this identity. All right, that's a little bit about the identity. And so we've enrolled it. Where's our enroll identity called? And then we're stuffing the result of the enroll identity. In this case, it's a global variable. It doesn't have to be global, but it is for easiness, into a variable. And then we're going to reference that variable down below right here where we run go server. And so now we're exiting. Oh, we got one more part of the automation. We have to create service policies. And so I want these to be demo client dial and demo server bind, which means I have to change this up here to demo server bind. And then I'm going to use, again, remember we talked about generators doing generator crazy things. This is one of those generator crazy things. The specification will tell you that there's basically an enum of dial binds, and in the enum of dial binds is, as you would expect, dial and bind. And so the structure that gets emitted is called dial bind dial. And no person would write that. That's just silly. You would just call it .dial or whatever. But because it's Go and because of how it all works, there's no name spacing. We could have this in a different package called dial bind. That might make sense too, but that's not how it's done. So if we go in and we look at that, you can see there are just two constants: constant called dial, constant called bind. You could use the string if you want to use the string, but it's nicer to be able to use a constant. And then we're going to give it some attributes. So I want demo clients, and I want demo servers, and I want demo services. Now, every time you touch code, you have a chance of screwing it up. And so we're going to have to test this in a bit, because I did change things. And when you change things, I don't know, sometimes bad things happen. Then we're going to call service.server. So service.server, what is this? This is actually a straight up copy of the reflect server that comes from the Golang SDK. If we go back over to, where was our Golang SDK? All right, we'll just type it back in again. SDK Golang. Oh, I had examples right there. Look at that. Go into here and we look at where is reflect, and we look at CMD. You'll see there's a client and there's a server. And here's how big the server is: 60 lines of code for the server. And you can see what the server does is standard Go stuff, right? Nothing fancy. You make a new ZD context, that might be fancy, or you use a new ZD context from your config. And then you call listen, very common Go pattern to call listen on a listener. So you have a listener that is created from context.listen, and then you serve the listener. And that's really all you do. Actually, this looks like it could probably use a Go routine. And then in the serve function, all you do is you call accept. You print out a little I accepted a connection, and then you call the accept function. And the accept function is simple. It just logs some stuff out. So we've already seen that all happen. And so this is just a straight up copy of that whole code. And you can see it's all the same stuff. And the reason why it's in this particular project is because what we are going to do is we're going to run clear, go build, and then run the project again. And now when this is, hopefully that works. Yeah, okay. Identity ID can't be found. Perfect. Like I said, whenever you touch something, you run the risk of breaking it. So let's take a look. Ziti Edge list identities. Got demo server. So let's go back and look at our error. It said identity ID. Ooh, can't be. That'll be a nice, we can find that. IDE somewhere, can't be found. So somewhere enroll identity passed reflect server, and it needed to pass demo server. All right, let's try to clear, rebuild, rerun our project. Failed to create the identity. Probably didn't delete demo server. Delete identity demo servers. Yep, that's the problem this time. One more time. Did we get it right this time? All right, now we're generating an ID. That's cool. Hey, and we even have 2 sessions. So to go back to Ziti parlance, if we do a Ziti Edge list terminators. Terminators, it's a term I don't particularly like. It's a good term. It makes a lot of sense when you understand Ziti, but the first time you see it, it's kind of confusing. Basically what this is saying is we have a place for SDK traffic to terminate at. So your client will send traffic to a terminator, and then the terminator will get, like OpenZiti will take care of getting your traffic to that terminator, and then the terminator has to do something with it. In a tunneler, the tunneler will open a new outbound socket to some place that you configured and actually shovel the traffic to the actual destination. But in our case, we have a server that we're writing, so our server is going to just handle that traffic. And so that's what a terminator is. And you can see we have 2 of them, because now let me go back over here and turn it off. If I turn off my server, terminators are all gone, right? That's what you would expect. So let's go ahead and rebuild the whole thing, relaunch the whole thing, regenerate, and start the server back up. So now what we have done, go back to the OpenZiti demo here. We have our little reflect server running in our local environment right here. And now this thing also, and this is part of the demo type stuff, this thing also provides port 18,000. We already saw that working way back at the beginning. So if we look for 18,000 in here, you can see we started the reflex server in a Go routine so that we could keep going. No pun intended. And then port 18,000 is used to create an underlay listener. And that underlay listener is then used to serve some HTTP based functions. And so we have a simple HTTP server, and we have a simple serve mux and a few endpoints that are able to be handled. And so one of those endpoints is slash. Slash will serve some index.html, and we can look at index.html if I can find it in here. And you can see it says add to OpenZiti as a type of submit. And wouldn't you know it, that's what this button is. So before I had, oops, not this one, Ziti Edge list identities. I'll make this bigger again so that we can do that too. Let's do it clear. So you can see we've got our demo server. Let's make a new client from our little environment here. New little client, we'll call it. It says, hey, congratulations, you now have a token. And so if we look, we can see new little client. Can already see we got a bug. I didn't update reflect.clients. So we got to start all over again. Let's go back and find not on this one, back here, reflect clients. But it's okay because this is the exact process, right? And so what we did with the add to OpenZiti function, as you might recall, that was one of the routes that we handle. So in the add to OpenZiti function, what we can do is we can parse the form, get the email address out, and it doesn't, like I said, it doesn't have to be an email. It's a work in progress. So I didn't provide an email. And then if the identity you provided already existed, we delete it. And we don't tell you that because we're just giving you this, for free and for automated purposes, making it easy. And then we recreate that identity using the exact same functions that we just talked about. We delete the identity, we create the identity, we give it the right attribute this time, and we get the token back, and we tell you, here's your created identity, come back and get your token. So you can come back and get your token ID. And so that's what we'll do this time around when we rerun our project. So let's turn it all off and turn it all on, rebuild it. back to the internet here. New little client. Actually, let's go and you don't have to do this. I'm just going to do this for completeness sake. Ziti Edge delete identities. Identity new little client. There we go. And we'll add that to OpenZiti. And now we can click download token again, and we get that token. Sorry, it's so small. I'm trying to keep it big enough so people can see it. And we are, so let's wait. Oh, come on, right here. Yeah. And so now if we list our identities, we'll see new little client. Demo clients. Good. We've made some progress here. Now what we can do maybe is we can run our reflex. Would this work? Anybody? No, this won't work. This token is old. I've deleted it. I've deleted the identity a bunch of times. It's no longer good. That identity is no longer good. So we have to do a Ziti Edge and roll, and we have to paste the JWT and let it re-enroll again because it's a brand new identity. Now it'll work. I'm sure of it. Hey, it actually did. I wasn't sure of it. Hi there. This is the new little client. And so there's a pretty cool demo, right? Now you're like, it's not so cool because this is not available to the open internet, but it could be available to the open internet, right? Like we have this cool new tool called Xerox. So I could actually do a Xerox share public on, let's do local, is it HTTP local host colon 18,000. What Xerox does is it actually uses the actual Xerox API out in the cloud. And so now technically everybody out there can go to this URL. It's hard to type in. So, but if you want to cheat and grab that real quick, anybody, I'm interested to see if anybody will take me up on the offer. 71 little u 4 little n l little n 0 little z little g inf dot share. If anybody's out there that wants to grab that, I'll leave it up and running. See if anybody wants to try this out. But you should be able to send me traffic on my new little client wherever you are, assuming you have the SDK and you build everything. So I don't know if anybody has any of that stuff running live. But hey, well, let's do it together. Well, why don't we just do it together? So I'll go out to here, and you'll see. Oh my goodness, it's the same. So we'll say it's this. No, let's not do that. You never know with apostrophes. We'll call it the same. Now I'll come over to here, and I'll be able to list my identities, and you see the same shows up. Let's do it clear. So now what would I have to do? What would you have to do right now? Well, right now, the first thing we'll have to do is go out to github.com, OpenZiti /SDK Golang, click the HTTPS button because you probably don't have access to it in any other way. Come back to your environment. This is in Amazon, mind you, right here. So I'm going to git clone that URL. Let's CD to SDK Golang, CD to examples, right? Yeah, reflect. Type go. I don't have gob on this machine, so I'm going to type make dir build. Go build -o build // Wait for this to download. In the meantime, we'll see if anybody else has come down through. Waiting for this. All right, so if we do our clear command again, anybody else? Nobody else yet. All right, it's fine. It's okay. I understand. So we've built our thing. Let's do a Linux. Actually, it's in build / reflect, right? Oh, did it build? A build. What didn't it build? Go. Let's try our go build again. Oh, go mod tidy is needed. Didn't realize that. You'll have to go mod tidy too, unless I push this up in time. We'll wait for the go mod tidy here. This will be the big pizzazz because I'm doing this, remember, from Amazon to my home computer, like in this room, that one right there. I'll do the go build Xerox too, which is awesome. If you haven't checked it out, check Xerox out. It's just chugging away out in Amazon land. It'll be done any moment now. I know the anticipation is really, it's palpable. Everybody feels it. Any moment now. You can see how much faster it was on my local machine. My poor little Amazon machine is probably having a hard time out there. You can do it. No, you can. We're almost there. I feel it. I feel it. Oh, oh, oh. Hey, yo, somebody did it. I don't know who did it, but great job. We got a yo. Please do be kind. It is a live stream after all. But somebody did it. Like, I don't know who it was. Well, we got somebody who did it. Let's see if I go and I list the identities. Oh, this build is taking forever. That's the sage. Okay, fine. Of course, that's how it works. Let's go back and look and see what identity they gave themselves. They gave themselves yo. What a great identity name. I love it. All right, so I've built this. Now I can do build, reflect, client. Actually, I've got to grab my token. I haven't grabbed my own token. And so we'll download this token. And I probably should give it a different name. So this is like a new.token.jwt, I guess. Exit here, cd back to temp, and then scp, my new.token, what do they call it? Yeah, new token.jwt to cd aws. SSH back to CD AWS, and then CD to SDK Golang example, reflect, copy the token, new.token to here, Ziti, it's not on my path, is it? Oh, and then we'll do .ziti / Kickstar IP. Oh, I didn't hit source. I need to source that. IP.env. Now I can do Ziti, edge, and roll new.token. I can do build. Here's the payoff. Build / reflect client -i new.token service name reflect service. Just like that. And look, it works from AWS to Clint's computer. Look at that. When we come back over here, it works from AWS to Clint's computer. What a great Ziti TV that was. I mean, I loved it. That was great. I think we did some cool stuff there. So we cleaned up a little bit. We learned a little bit about how to automate the OpenZiti overlay network using a Go-based API that wraps our HTTP API. We learned a little bit about how we could use the Reflect client to do some really simple stuff, and obviously we could do HTTP type stuff too. Yeah, and I thought that was fun. So thanks everybody for hanging in there. It's been 53 minutes. Anybody, whoever yo was, you're my hero. Appreciate it. We'll see you guys next time.